We'll proceed in the case study of Jacobian in calculus. We are doing case study in Jacobian in calculus. Case study in a sense that we are taking example. So theory is over, and with example also we tend to learn many things. So the example arena, like a method of substitution in integral calculus, later it leads to Jacobian. So in calculus, in integration, there are three parts. One part is limit, one part is limit, another part is integrand, and one part is differential. Sometimes, so limit integrand, that is a function over independent component. Limit, where independent component has limit. Independent components has limit. And then function over independent component and the differential. Dx, dy, if the independent components are x and y. Fxy, that is z. Fxyz, that is density. If that is the case, then it is dxyz, dx, dy, dz, and the limit is a three-dimensional limit. If it is fxy, dxy plane, the limit is two-dimensional. This is what we have seen. Means surface knowledge is all right if problem is small, but if you know this is going to be your career, this is going to be someone's kind of, it is going to be someone's future, and then it is something like more tedious thing would come in the future. In that sense, deep knowledge is required. So method of substitution, it looks very simple. Quickly substitute something with something else and change the limit, change the differential, you get the result. People generally they do it in two dimensional, in single dimension. Like we have already given example of a capacitor. There is a voltage source. There is a voltage source. Voltage source is, I always think that I'll bring the capacitor, but somehow I never bring. Okay, so there is a RC circuit. RC circuit means there is a resistor. Resistor is connected to capacitor in series. Resistor is connected to a capacitor in series, and capacitor is connected to a voltage source, and voltage source is connected to resistor. So all are in series. This is called RC circuit. Voltage source Vs. Vs is connected to resistor R. R is connected to capacitor C, and C is connected back to voltage source, negative plate of the voltage source. Now, if this voltage source is connected to this RC circuit, immediately current would flow. Resistor means it resists the flow of the current. Resistor means it resists the flow of the current. Capacitor means a device which has some capacity, means it builds its own voltage. That's why it is capacitor. It has the capacity to generate voltage, means it will store the energy. Voltage source is a battery because there is a energy stored in it. There is a charge that is stored. There is a negative plate, positive plate, and charge is stored in the battery. And this charge is finally flowing as a current to resistor, which resists the flow of the current. To capacitor is another voltage source which stores the charge. If it is storing the charge, it will start behaving like a battery. Okay, so at the beginning there is no charge in the capacitor, so it will behave like a short circuit, and current it would flow as if there is only resistor in the circuit, but slowly charge would get stored in the plates of the capacitor, and slowly it will start building up the voltage. Generally I say electronics is game of resistance. Means capacitor, if charge is getting stored in the capacitor, voltage will start building up, then it will start kind of opposing the voltage in a way that at the end it will start opposing the current. When there is opposition of the current, there is a resistance to the current, Means capacitor has a resistance. Initially resistance is zero, resistance is slowly growing. Capacitor is nothing but in electronics term it is a variable resistor. Variable resistor. Now voltage across capacitor at any moment V equal to Q by C. How much charge it has stored divided by the capacitance. So if beginning charge is 0, then voltage is 0. The way charge is building up, voltage across the capacitor is growing. dV by dt equal to dq by dt into 1 by c. 1 by c into dq by dt. Charge per second that is getting stored. Charge per second means flow of the charge is nothing but the current. More charge is coming, more charge is flowing, means more current is flowing. dq by dt is the current. So dv by dt is inversely proportional to the capacitance. dv by dt equal to 1 by c. Means if capacitance is high, then change in the voltage across the plate will be slow. It will charge slowly. It will discharge slowly. If capacitance is low, less value, quickly it will charge, discharge, charge, discharge. It is something like that. So dv by dt equal to 1 by c I. dq by dt is I. Now voltage across resistor, current across resistor is variable. Current across resistor, resist, resistor, resist, provide resistance to the current. It resists the current. It's true, but it does not store any. But it does not store any energy. So voltage across capacitor at any moment, voltage across capacitor at any voltage across resistor at any moment is resistor into I. I is variable because of capacitor is connected. Now I equal to C dV by dt because same I is flowing. So I current across the capacitor at any moment is I equal to dV by dt into C. Now voltage across resistor is RC into dV by dt. Now voltage across resistor plus voltage across capacitor is the net voltage, that is Vs. So Vs equal to RC dV by dt plus V dV by dt, where V is the voltage across capacitor, now plus voltage across the capacitor. So Vs equal to Cv dV by dt plus V. If you settle down, then it will become Vs Cv dV by dt equal to Vs minus V, or d 1 by Vs minus V, 1 by Vs minus V dV equal to 1 by Rc dt. Now, at any moment, if I want voltage, I have to integrate it. And if I integrate it, how I can integrate it? dV by Vs minus V. dV by V I know. dV by minus V I know. dV by Vs minus V, where Vs is constant, R is constant, C is constant. dt, T is variable, time is changing, and V dV, V voltage across capacitor is changing. Now method of substitution comes into the picture. Okay. Now someone would quickly consider Vs minus V equal to U. Then dV equal to minus du. Now dV I can replace with minus du. Minus du divided by U. Minus I can take outside. It is ln U. ln U. Now ln U. What is U? U is nothing but Vs minus V, ln Vs minus V. Now limit, the integration limit is voltage is 0 to voltage is V. V is variable, ln Vs minus V. ln, first is ln Vs, V is 0, ln Vs minus ln Vs minus V, V, ln Vs minus ln Vs minus V. That is, okay, I believe I am talking right. Okay. If Okay, if that is the case, then it is ln Vs minus V, something like that. I'll try it again. Okay, so now I have minus outside and limit is 0 to V, and it is dV, it is du by u, ln u, ln u. Now, if it is ln u, if it is ln u, then if I take u equal to Vs minus V, ln Vs minus V. V first, oh, lower limit to higher limit. First, I have to substitute V. So ln Vs minus V, then lower limit minus ln Vs, ln Vs minus V by Vs, ln Vs minus V by Vs. Minus was outside, I can keep that side. Now that side minus T by RC. Now Vs minus V by Vs equal to e to the power minus T by RC. So V equal to Vs 1 minus e to the power minus T by RC if you settle it down. Now person is feeling kind of proud. See, just method by substitution, I solved it. But there is a big world behind the method of substitution. Person does not do that what he has done. So he just quickly modified dv to du. But internally dv is nothing but dv by du into du. dv by du into du. This dv by du, you cannot directly convert dv to du. dv equal to dv by du into du. dv by du is called Jacobian. So here we are changing the differential. When we change the differential part of integration, there we introduce Jacobian. That's how we complete the differential part of the modifying the differential part. What about the integrand? Whatever substitution I have taken, I can just replace in the integrand and then the limit. Okay, here I got back u to v again, but I can all along change the everything in u only. If I do so, then what about the limit 0 to v? Now u equal to vs minus v. If v is 0, then u is vs. So u will start from vs now, and then 0 to v, then u will be vs minus v. If I take everything in u only, then u will start from vs to vs minus v. Earlier it started with 0 and v. So this is the kind of called method of substitution. Three parts: integrand modification part, differential modification part, and limit modification part. Why you are talking this much? Because if we go in 2 dimensions, 3 dimensions, where two independent variables are there, or we go to 4 dimensions where three independent variables are there, dx, dy, dz. Now here only dv, dx, dy, dz. What about 100 dimension? What about 1000 dimension? This is what is going to come in machine learning, artificial intelligence. In that sense, person has to understand the full concept behind it. Then only method of substitution would work. So that is the fashion. Okay, if that is the scenario, now people generally start with the integrand, then they tackle the Jacobian part, then they tackle the limit. It should be other way. Person should first tackle the limit, then he should tackle the Jacobian, then he should tackle the integrand. That is the science, because limit can make someone's life hell, especially when independent components are two or more than two. No independent, all the independent. If I say limit is a interval, if you see this capacitor example, the limit is interval 0 to v, 0 to v, 0, 0 to v. 0 is numeric, v is variable. Okay, it should be it should be numeric value. But anyway, we deliberately want value. We don't want numerical value at all. Numerical value means at any time or time equal to 1 millisecond. At that moment, at time 1 millisecond, at that moment, what is the voltage? then 0 to 1 milli, then time equal to 1 millisecond, what would be this? Then voltage will be 0 to be there in dt, integration will be 0 to 1 millisecond or something like that. So this is the requirement. But situation is nice if this should, the limit should be kind of, it should be in a numerical fashion. Like, yeah, like we are taking example now. One example that is a kind of assignment that we provided in the last session video. That is like there is an integrand. Integrand is fxy. Integrand is fxy. Integrand is fxy. If integrand is fxy, then there is xy plane. If integrand is fxy, means the independent component is xy plane. Independent component is xy plane, not x-axis and y-axis. Independent component is xy plane. If independent component is xy plane, then fxy function over x comma y and dxy plane, and then limit is the region on xy. Many times we have demonstrated it. What is the limit? Consider this is a surface on top of this xy plane. This is xy plane. On top of xy plane, there is a surface. Okay, and I want to calculate volume of this surface. What is volume of the surface? If surface is like this, can someone calculate the volume of the surface? If I drop it, this surface, if I go down, 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 down and touch the xy plane, then if I do like this, then there is a region on xy plane, it is making intersection. That region is this, this, that is a rectangular region. And when it falls, it makes a cuboid, rectanguloid, okay, where the height is this much and then rectangle. Rectangle, consider the width is W, and length is L. Then length into width into height, that is the volume. So if someone calculate the volume, anyone can try. Consider this plane equation is 3. Plane equation is 3 or plane equation is H. H means you take any x or y, Z will be H only. Now, someone has to find the volume underneath this surface, full volume underneath this surface, where the xy, what is the equation of the surface? Equation of the surface is H, provided xy, x and y must be within, x must be within minus w to minus w by 2 to w by 2. Y must be in xy plane, y must be minus L by 2 to L by 2. Minus w by 2 to w by 2, both are numeric. And minus L by 2 to L by 2, this is also numeric. This is what is expected, that whatever the xy value, if I take in the integration, it must be intersection of this surface. So xy value I cannot take for the full xy plane. Xy value I have to take inside this rectangle only, where there is the intersection. So there is a limit in the xy independent component. With the independent component, if I apply function over independent component, z value comes into the picture. Z equal to function over x comma y. But x comma y, the x comma y, this is the variable, independent component or algebraic variable. Their value must be in a region. It cannot go beyond it. That region is the limit. So limit is the xy region for which we are trying to find the volume, and fxy and dx dy. Fxy is h, dx dy, and limit x is minus h minus w by 2 to w by 2, it is minus L by 2 to L by 2. Now h is being constant, I can keep outside. Dx, now minus L by 2 to L by 2, L, minus w by 2 to w by 2, w, and that is L. WLH, this is what we are saying, the volume of the cube. Now the situation is whenever we go for the limit must be rectangular or tends to rectangular. Limit cannot be that y equal to x to the power 3 plus sin x plus cos x e to the power x to x to the power 4 sin x sin square x sin 2x plus e to the power x plus ln x. Okay. So the idea is that limit region must be rectangular. If not rectangular, then it should be as close to the rectangle. So many times we go with the kind of different kind of situation. The example what we took is, I don't know what is the integrand is. We are calculating volume. So there would be integrand fxy, dx, dy. Now the limit region for which we are giving example now, the limit region is that there is one y-axis. There is one y-axis. X and y must be picked up from the particular region on xy plane. There is one y-axis and there is one line called x is equal to a square root of 3y. Okay, so okay, so this is y-axis, this is x-axis. Now there is a circle that is centered at the origin. There is a circle that is centered at the origin. Now if I take this arc, okay, if this is the circle centered at the origin, there is an arc. Okay, there is an arc or circumference of the circle. That equation is 9x square plus 9y square equal to 64. Or rather I would say x square plus y square equal to 8 by 3 whole square. Means radius is 8 by 3 x square plus y square. That is a circle. There is another circle that is small circle. Bigger circle, a smaller circle. 4x square plus 4y square equal to 1. Rather than I can say x square plus y square equal to 1 by 2 whole square. The radius is 0.5. Now we are trying to calculate integration for the xy plane. Region is like a circular strip where inner circle is excluded, where the inner circle we have excluded. If that is the scenario, inner circle we have excluded. If that is the scenario, means inner circle when I am excluding, then that is the arc patch we are calculating. Not only that, now it should be, there is another limit called y-axis, and there is another limit called, there is a line called x equal to square root of 3 into y. Y-axis means x equal to 0. Another is x equal to a square root of x equal to a square root of 3y. Or I mean it is difficult. Let's do another thing. Now this is x equal to 0. This is y equal to 0. X-axis is y equal to 0. Now limit is x equal to 0, y equal to 0, x equal to 0, y equal to 0, then x square plus y square equal to x square less than x square, or x square plus y square equal to 8 by 3 whole square, x square plus y square equal to 1 by 2 whole square. These four are the limit. Okay, whereas differential is dx dy and integrand is something. Now that's why I say first tackle the limit. Limit can make anyone's life hell. What would be the limit here? Limit I can set. What would be the transformation in matrix? Now you consider the limit, right? Limit is one circle is anyway head breaking, then there is one more circle and patch in between that. Not only that, then x-axis and y-axis, whatever comes in between x-axis and y-axis, this patch I have to calculate. This is the reason. Now can someone, because this is not tackable, okay, no one can tackleable, no one can tackle it as far as xy coordinate system is concerned. If that is the case, then what someone can do? That is the question. Someone can go for another coordinate system. Typically, people would not jump for the polar coordinate system because it is giving a circle x square plus y square. It tempts people to use x equal to r cos theta, y equal to r sin theta. Okay, if that is the case, then what would be the limit? So what would be the transformation function? So we can take transformation function as as polar coordinate system. If I take transformation function as polar coordinate system, if I take transformation function as polar coordinate system, then someone can tackle it. Okay, then what would be the limit? Now, as per the transformation function as polar coordinate system, now someone can proceed and change the integrand. If it is wherever it is x, now he can think of r cos theta. Wherever y is there, he can think of r sin theta. Dx dy. Now dx dy is nothing but dxy plane. Dxy plane by d theta r into d theta r. D theta r is d theta dr and dxy by d theta r is Jacobian. If there is a means if we are thinking in xy plane there is a circle, then with the new transformation where x equal to r cos theta and y equal to r sin theta in theta r plane, there is a rectangle. This is what exactly we want. We want the limit, the xy limit region should be a rectangle where theta is x-axis and r is y-axis. There is a rectangle where theta goes from one limit to another, r goes for one limit to another. This rectangle get mapped into a circle in xy plane. Means we are delegating this xy plane calculation to theta r plane, because theta r plane is guaranteeing me that limit will be a rectangular region, not the circular region, what you are thinking. And then just think, what is the limit? X equal to 0, y equal to 0, x square plus y square equal to 8 by 3 whole square, x square plus y square equal to 1 by 2 whole square. Start hitting your head against the wall. Now here there are only two. Here there are four. There are only two. Theta one place to another place, or one place to another place. So nice. Dream, right? Now Jacobian for this is r. R factor is getting introduced as a new new headache. But it's all right. Bigger headache we are removing. Then d theta dr and the integrand. Now, what is theta and what is r if it is x and y, x-axis and y-axis? Okay, now we will start tackling it. Now, y, if I see y, if I see circle, okay, if I see circle, then there are two circles. One is bigger circle. So, if I say this is a y value, then y value, if I say this is x square plus y square, let's go with this one. X square plus y square equal to 8 by 3 whole square. There is an inner circle, that is x square plus y square equal to 1 by 2 whole square. Now x is r cos theta, y is r sin theta. X square plus y square means r square equal to 8 by 3 whole square. R equal to 8 by 3. Now here r equal to 1 by 2. So r is 1 by 2 to 8 by 3. So simple, right? X square plus y square equal to 8 by 3 whole square. X square plus y square equal to 1 by 2 whole square. R equal to 1 by 2, 1 by 2 to 8 by 3. Both are numeric, whatever it is. Same complexity. Amazing, right? Now what about theta? What about theta? That is in question mark. Now x equal to r cos theta, y equal to r sin theta, y by x equal to tan theta, theta equal to tan inverse y by x. Now one place, this is y axis, means x equal to 0. Tan inverse y by x, if x is 0, tan inverse infinity 90 degree. Another is y equal to 0, numerator is 0, tan inverse 0 means 0, 0, 0, 0, 0 to 0 to pi by 2, 90 degree means pi by 2. Integration is 0 to pi by 2 theta. R is R is 1 by 2 to 8 by 3. Now in theta R plane, this is a rectangle, simple rectangle, where theta is going from 0 to pi by 2. If I see the theta R plane, if I see the theta R plane, this is theta and this is R. If this is theta, then this is R. Now in theta 0 to pi by 2, R is 1 by 2 to 8 by 3. So this is a rectangular patch and integration limit in this region, the rectangle. So go with the rectangle. If it is not rectangle, then mold it. Okay, I want a straight line. I don't want this kind of curve line. What was problem there? X equal to 0, y equal to 0 line is all right. But if I see x square plus y square equal to 8 by 3 whole square, then y equal to square root of 8 by 3 whole square minus x square. Here y equal to square root of 1 by 2 whole square minus x square. Y is dependent upon x and not linearly. See, x square and then minus and then square root. Y should be independent of x. If it is dependent also, it should be linearly dependent. Y equal to some 3x, 4x, x, minus 1 by x by 2 or something like that. Not 8 by 3 whole square minus x square root. This kind of thing is not digestible. If this will go in integration, if someone calculate the dy integration and this limit goes there, just think for the dx, that is the next. First I do integration with the dy. And if I am done with the integration, then I'll set the limit. If I set the limit in a square root of 8 by 3 whole square minus x square, and anyway there are x in the integration result factor, how much complexity it will add when I am going to do integration with another differential dx? Impossible to integrate. Now r, if I do integration with theta r, first I do with the r, and r is one scalar to other scalar, full r will go away at all completely. Here x will not go away, instead it is pushing against the, here if I do integration with the dy, then it will be in term of x and y. Y, if I put a scalar value, numeric value, then it will be only in term of x for the integration with the x. Not that, instead of y, it is introducing a square root of 8 by 3 whole square minus x square, and another will have square root of 1 by 2 whole square minus x square. X is anyway there. Now for the dx, it is adding the it should reduce the complexity, it is adding the complexity. So that much is not absorbable. No one would absorb it. That is too difficult. That's why we say limit region must be rectangular. If not rectangular, if they are collinear in artificial intelligence term, if features are collinear, then they should be in a monomial fashion. They should be collinear, not in binomial or this kind of a very typically difficult kind of scenario. Okay, now we'll come back to the real question. One is y-axis and one is x equal to square root of 3y, and then other two are same. X square plus y square equal to 8 by 3 whole square. X square plus y square equal to 1 by 2 whole square. Now the r would be same, 1 by 2 to 8 by 3. That is the r. What about theta? Theta equal to tan inverse y by x. If I say y-axis means x equal to 0, in that sense it is pi by 2. What about this line? This is y-axis, there is another line, x equal to y into square root of 3. dy by dx is numeric positive, means this line is perfect. dy by dx is negative, means it will go like this. Okay, in this quadrant it will go. Dy by dx is positive, means it will, in first quadrant it will be like this, in third quadrant it will be like this. Dy by dx is negative, means it will lie in fourth quadrant and second quadrant, this way. So it is positive, so it is like this. Now, now d tan now theta is tan inverse y by x. Then x equal to y into square root of 3. Then tan inverse 1 by root 3. Simple. So theta would go tan inverse 1 by square root of 3, whatever comes. It is a scalar value, no problem, to pi by 2. So for the integration limit is tan inverse 1 by square root of 3 to pi by 2, that is theta, and r is 1 by 2 to 8 by 3, and dx dy is r d theta dr, and then the integrand someone has to modify and solve the problem. What is another example? Another example is also very famous. This is x-axis. This is x-axis and this is y-axis. This is x-axis and this is y-axis. There is one line like this. An equation is x plus y equal to 1. There is another line parallel to it. Equation is x plus y equal to 3. X plus y equal to 3. X plus y equal to 1. So there is a region in between it. And y equal to 0, x equal to 0. Whatever the strip is coming, it is called trapezoidal region. Okay. So trapezoidal region. So that region trapezoid. So that region, trapezoidal region, where x intersection is 1 comma 0, 2, 3 comma 0. Y intersection is 0 comma 1, 0 comma 3, and then this line in between is this strip, that is the region. Now integrand is x minus y whole square e to the power x plus y, and dx dy. This is the limit. Limit region is x plus y equal to 1, x plus y equal to 3, x equal to y equal to 0, x equal to 0, whatever comes as intersection, and then x minus 1 whole square e to the power x plus 1 dx dy. This is the assignment. Someone can now calculate the integration. Now please support us, and kind of it helps us. +91 is India country code 9483160610. This is the telephone number 9483160610, and +91 is the India country code.